This is the $7 trillion lie. Big tech tells you AI is the future, but they are hiding a physical reality that is about to crash the entire system. Here is the problem. ChatGPT doesn't just run on code, it runs on electricity, massive amounts of it. Right now, a single AI search uses 10 times more power than a Google search, and as models get smarter, they get hungrier. Microsoft and OpenAI are building a supercomputer called Stargate. It will need 5 gigawatts of power. That is not a data center. That is the energy consumption of a small country. Where will this energy come from? It won't. The grid is full. We are hitting a wall. The physical reality. To understand the magnitude of this problem, we need to stop looking at screens and start looking at the ground. We tend to think of the internet as a cloud, something weightless and invisible. But that is the first lie. The internet is made of steel, concrete, and copper. It is heavy and it is incredibly hot. When you ask ChatGPT a simple question, that request travels to a data center. Inside these massive warehouses, thousands of graphics processing units, or GPUs, roar to life. They perform billions of calculations in a fraction of a second. This process generates an immense amount of heat. So much heat, in fact, that cooling these systems has become an engineering nightmare. Traditionally, data centers used air cooling, giant fans blowing air over the chips. But the new H100 chips from Nvidia are so powerful that air is no longer enough. They are literally too hot to handle. Now we are moving to liquid cooling. We are pumping water directly into the servers just to keep them from melting. This brings us to the scale of consumption. A standard Google search uses about 0.3 watt-hours of electricity. A ChatGPT query uses nearly 3 watt-hours. That is 10 times the energy for a single interaction. Now multiply that by the billions of queries happening every day. We are seeing energy demands that rival entire nations. In Ireland, data centers now consume more electricity than all the urban homes in the country combined. And this is just the beginning. We are currently in the early stages of AI adoption. As these models move from text to video, and from video to creating entire virtual worlds, the energy curve will not just go up, it will go vertical. The grid, as it stands today, physically cannot support this. The nuclear desperation. The tech giants saw this wall coming long before the public did, and their reaction tells you everything you need to know about the severity of the situation. They are in panic mode. They are no longer just software companies, they are becoming energy companies. Look at Amazon. In a move that shocked the industry, Amazon Web Services purchased a data center campus in Pennsylvania explicitly because it was directly connected to the Susquehanna nuclear power plant. They didn't just buy the servers, they bought the rights to the nuclear energy itself. Then there is Microsoft. They have signed a deal to reopen 3 Mile Island. Yes, that 3 Mile Island, the site of the worst nuclear accident in US history. They are so desperate for stable, carbon-free baseload power that they are literally resurrecting dead nuclear reactors. Google is exploring small modular reactors, or SMRs. These are essentially mini nuclear plants that can be deployed right next to data centers. The strategy is clear: off-grid power. They know the national grid is too slow, too old, and too congested to give them what they need. This is a massive pivot. For years, these companies bragged about wind and solar, but wind doesn't blow 24/7, and the sun doesn't shine at night. AI training runs cannot stop. If the power cuts for even a millisecond, millions of dollars of training data can be corrupted. They need consistent, massive power, and they need it now. The irony is palpable. The companies that promised to disrupt the old world are now the ones keeping the oldest, most controversial forms of energy alive. The dirty truth. This energy hunger brings us to the dirty secret that nobody in Silicon Valley wants to talk about: the return of fossil fuels. For the last decade, the world has been trying to shut down coal and natural gas plants. We were making progress. But AI is reversing that trend almost overnight. In states like Virginia, known as Data Center Alley, utility companies are sounding the alarm. They are keeping old, polluting coal plants online years past their retirement dates simply to keep the lights on for these server farms. In Kansas, massive coal plants scheduled to shut down are now staying open to support the load. The grid itself is becoming a dangerous bottleneck. It is not just about generating power, it is about moving it. We are running out of physical infrastructure. The wait time for high-voltage transformers has gone from weeks to years. This creates a zero-sum game. If a data center sucks up all the clean, cheap renewable energy in a region, what is left for the rest of us? Local residents and small businesses are left with the expensive, dirty mix. Energy prices in data-heavy regions are projected to rise significantly. You might not use ChatGPT, but you will likely pay for it through your monthly electricity bill. And it isn't just electricity, it is water. Google's data centers consumed over 20 billion liters of water in a single year to cool their chips. In drought-stricken areas, this is water that is not going to farms or homes. The promise was that AI would solve climate change. The reality is that AI is currently accelerating the problem, demanding a physical toll from the planet that we simply cannot afford. The profit problem. This brings us to the most dangerous part of the equation, the economics. Building these massive, power-hungry data centers is costing trillions. But here is the uncomfortable question Wall Street is starting to ask. Where is the profit? Sequoia Capital, one of the biggest investors in Silicon Valley, recently crunched the numbers. They estimated that the AI industry needs to generate $600 billion in revenue per year, just to pay back the current investment in chips and energy infrastructure. Right now, they are nowhere near that number. The problem is the inference cost. Every time you ask an AI to write an email or generate an image, it costs the company money in electricity and computing power. Unlike Google, where a search is incredibly cheap, AI is expensive to run. It is like driving a Ferrari to deliver a pizza. The cost of the fuel is higher than the value of the delivery. If electricity prices rise because of the scarcity we discussed in the previous scene, the margins get squeezed even tighter. We are seeing a massive cash burn. Companies are spending money like there is no tomorrow, betting that AI will eventually become profitable enough to pay the massive electric bill. But if the grid taps out, or if energy prices spike, that business model collapses. This is the definition of a bubble. Asset prices, in this case AI stocks, are inflated based on future promises that face a physical, energetic wall. If they cannot get the power they need at a price they can afford, the projected profits vanish, and the bubble bursts, the hardware shortage. Even if we ignore the cost and the pollution, there is another hard wall, the supply chain. Elon Musk recently summed it up perfectly. He said, "My prediction is that we will run out of transformers next, then electricity." He is right. The physical grid cannot be upgraded with a software update. It requires heavy industrial machinery that takes years to build. Right now, the wait time for a large-scale, high-voltage transformer is up to 3 years. These are massive, house-sized components that regulate power flow. There are only a handful of factories in the world capable of building them. They are completely booked out. So tech companies are sitting on piles of Nvidia H100 chips worth billions of dollars that they cannot turn on because the local substation is waiting for a part that won't arrive until 2027. This creates a massive inefficiency. The most advanced technology in human history is being held back by 20th century infrastructure limitations. And it is not just transformers. It is the copper cabling. It is the skilled labor. We are facing a shortage of electrical engineers and line workers needed to physically install these upgrades. The grid is an incredibly complex machine, and we are trying to overclock it without upgrading the cooling system or the wiring. This bottleneck means that the exponential growth AI promises is simply impossible to execute in the real world. The curve will flatten, not because the code isn't good enough, but because the concrete and steel can't move fast enough. The green mirage. So why can't we just cover the deserts in solar panels and be done with it? This is the most common counter-argument, but it fails to understand how a data center actually works. A ChatGPT server farm is not like your house. It never sleeps. It runs at 100% capacity, 24 hours a day, 365 days a year. It needs what engineers call baseload power, a flat, steady line of electricity that never wavers. Solar and wind are intermittent. The sun sets, the wind stops blowing. To run a data center on renewables, you need massive batteries to store power for the downtime. But the scale of battery storage required for a gigawatt-class AI cluster is astronomically expensive. We literally do not mine enough lithium on Earth to build the batteries needed to back up the projected AI growth entirely with renewables. This creates a dangerous gap. When the sun goes down, these green data centers quietly switch back to the grid, which is often powered by gas or coal. Tech companies buy carbon offsets to make their reports look green, claiming they are 100% renewable. But in physical reality, electrons are electrons. If the local grid is dirty, the AI is dirty. We are seeing a clash between physics and marketing. The marketing says AI will save the planet. The physics says that to run these chips around the clock, we need dense thermal energy sources. This is why the dream of a purely solar-powered AI revolution is, for now, a mathematical impossibility. The verdictity. So where does this leave us? We are witnessing a collision between an irresistible force, artificial intelligence, and an immovable object, the physical power grid. Something has to give. The $7 trillion valuation of the AI industry is built on the assumption of infinite growth. It assumes that computing power will keep doubling and costs will keep falling. But physics is calling that bluff. We are entering an era of energy scarcity. This doesn't mean AI will disappear, but it does mean the bubble of hype is about to burst. We are likely heading towards an AI winter, where progress slows down not because we lack ideas, but because we lack the juice to run them. The companies that survive won't necessarily be the ones with the smartest code, but the ones with their own power plants. For you and me, the consequences will be felt in our wallets. As data centers gobble up the cheap energy, residential prices will climb. We are effectively subsidizing the training of models that are designed to replace our jobs. The next time you hear a CEO talk about the unlimited potential of AI, look past the screen. Look at the smokestacks, the copper mines, and the power lines. That is the real machine, and right now the red light is blinking. The limitless digital future has a very physical limit, and we just hit it.